Precalc textbook and found this nice little section of rectangular to polar ones. I figure we could just kind of work through a handful of them, see how it goes. And then you should have access to the review and the solutions to that. And you can go from there. The ones that I would do if I were you, because I think we did ones that kind of looked like those, maybe even almost those exactly. Realistically, any of these are all good ones. They're all good. It's just that some of them won't have exact unit circle theta values, and then some of them will. So if you want ones that are going to end up being, kind of nice, I would look at these four. Okay. And then I think these two. Okay, those will end up being nice. So maybe focus on those. Just try a couple. And then jump on a canvas and you can pull up the review. It was 12 pages long. I'm not going to print that out. That's just a waste for about 13 multiple choice quiz to prepare for. So you can access that digitally and work through anything that you need to there. And we can talk about answers. And it's going to be just a chance for you today to try some of this stuff out. So, but just as a super quick reminder on how to do it right, we're trying to go from xy, which is what's given, to r theta. Okay, that's really the only thing I think about this quiz tomorrow, this trig final tomorrow, that's new, and even this isn't super difficult as long as you know how to do it, right? R is the square root of x squared plus y squared, and then theta is the inverse tangent of y over x, okay? And I would always suggest draw a little sketch for yourself, put the point in the right quadrant. Doesn't matter if you draw it perfectly, but get it to a spot that makes sense so that when you actually find theta, a lot of times with tangent, you'll get two different answers, right? It could be a first and a third quadrant, it could be a second and a fourth quadrant kind of answer. You want to make sure that you're picking the right one. And if the calculator gives you a first quadrant answer, but you know it's supposed to be the third quadrant run because x and y are both negative, then get it into the third quadrant using your reference angles. Okay. So anything boxed in blue, I think, just kind of looking at it real quick, should give you unit circle results. Let me see.
How many questions are going to be on the test?
13.
Oh.
All multiple choice.
Wow.
Yeah.
Nice.
Which is why we're taking it on a shorter Friday, because that's still more than 3 minutes per question. You'll need one per question, probably, realistically. So, I'm going to change my mode into degrees, because it is going to be very easy for me to do inverse tangent and know what the answer is if it's in degrees. So if I did like inverse tangent of, I don't know, like something for like 38, right? It's the inverse tangent of 1. That's 45 degrees. And -3 is not in the first quadrant where 45 degrees is. I have to get myself into the third quadrant using a 45-degree reference angle. Calling it 225, calling it 5 things like that. Okay, so just be careful with those kind of answers. I didn't look closely enough at the actual list of multiple choice questions, but if I were designing a test and it was something like number 38, right, which is in the third quadrant, but the inverse tangent is going to give you 45 to start, I am absolutely putting pi over 4 as one of those answers to try to get you. Right? That's how they're going to design these quizzes or these tests. They're always going to have a very similar, seemingly correct answer as one of the possibilities if you just kind of fall into autopilot mode and let the calculator tell you the answer. So just be careful with stuff like that. I think we did ones kind of like 35 or 37. 42 is a nice one too. Root 3 over 3 is what that negative root 3 over 3. Let's see, inverse tangent of negative. And you can just do 1. You don't have to rationalize. What is that? Inverse tangent of negative 1 over square root of 3. Yeah, negative 30 degrees. So that's good. It's positive x, negative y. So I'm in the 4th quadrant. So 330. So 11, 5, or 6. Yeah. So I like those 6 as good practice. And then, like I said, or I might have said yesterday, the quiz itself obviously is not available, it's not populated with the questions yet. I'm going to do that tonight. But to do that, I have to unpublish it. And so I linked the review and the review solutions to today's announcement. So those will always be there, so you don't have to worry about finding a way to get there. The other thing I'm going to do, actually I'll do this right now. I will copy these list of topics and I will put it on today's announcement. So you know what's in there. Back to the textbook for a little bit, and then, but don't just do rectangular to polar stuff and then stop. You want to make sure that you're going back and looking. You want to make sure that you have that cheat sheet. Like, check now to make sure you have it, so that tomorrow morning we're not scrambling looking for one. Make sure your calculator is charged today, so it's good to go. Make sure that your computer is charged. I'm not sure how I'm going to, like, I don't know. Like, I've been trying to figure out the logistics of doing this digitally, but trying to maintain test integrity. I think I'm just gonna have to trust you. So, yeah.
Can you, like, giving the quiz, can you, like, look and see if it's
Could you see if it's what?
Can you, like, see if it's put off the page?
Yes.
Could you do those a little bit so we can, like, see if we got them right?
Sure, yeah. Let's see. So, I'll put them on the side here. Let's go green. So 35 should be 7, 5. 36. Oh, that's weird. Okay. 36, 0, negative 5, so that'd be 5, and then 3 pi over 2. 37 is root 2, and then pi over 4. 38, that's got to be 3 root 2. And then 5 pi over 4. 41 would be 3, comma, same angle, 5 pi over 4. And then 42, let's see, 2, that's kind of nice. And then 11 pi over 6.
Bigger than 36. And would that be pi?
0. So my x is 0, so I don't go left or right. Negative 5. I am down along the y-axis. That's 270 degrees down there. That's 3 pi. 0. Negative 5 is down here, so I'm opening up this angle to get there. Right? I think they're right.
I think they're good. But if you were to plug it in for tan of negative 1,
You get negative 90.
wouldn't you get 180 again though? Because it
For
would
which
be-
one? I'm sorry.
For 36.
36.
Because I understand the graphing method that you have.
Right.
You do -5 over 0.
Which is undefined. The tangent of 3 pi over 2 is undefined. And so if you ever plug that in, like if I plug in the inverse tangent, let's see, -5 divided by 0, it should say undefined. Yeah, error, operation is not supported. There's a vertical asymptote at every multiple of pi over 2 plus k pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Because its tangent is y over x, and if x is 0, we're not going to get an answer there. So that's why I think it's really helpful to draw the sketch, because if I can draw the sketch, sometimes I can just look at it and know exactly where I am in terms of the radian measure to get there. I don't think that's the one. Like, I don't think it's an undefined tangent spot. I don't think it's on the y-axis. I think it's in a quadrant somewhere on the test tomorrow. So we don't have to worry about that. Let's peek and be sure, though. Yeah, it's in a quadrant somewhere, so we won't have to worry about that. I think it's just the one. I think that's the only one. But you don't have to do all 6. Once you feel like you get a hang of it, maybe you try half of them. Try every other one or something. You should be in pretty good shape. And then jump onto Canvas and take a look at today's link to the solution, or to the, well, you can look at the solutions, I guess, but look at the one that doesn't have the solutions. Just start working your way through them. I hand selected the important ones, okay, and I listed out the topics. If there's a topic on there that you just want to see a couple more, I spent last night grading rather than writing more practice ones. So your grades for quiz 3.1 will go in today if they haven't yet. I think I have everything graded there. And then 3.2 are stuff from a couple of days ago. That'll go in next. But after tomorrow, seniors, that'll be the last thing you get to me in terms of work to hand in. Next week, we'll just learn a little bit. Everybody else will have our chapter 4 test during finals week. Yeah.
Can you go over how to switch between logarithm and exponential form?
Or is there a question like that?
Yeah, whether or not that would be.
Let's see.
Number 4.
Number 4. Oh, this is the wrong one. That's 110. I don't want 110. Did I put the wrong one on there? Oh, man. Okay, that's probably why.
I mean, it said spring 2019.
Well, it's just the review. It's the same review, but that's the college algebra one. That's not the college trig one. Shoot, that's going to be different. That makes no sense. Okay. Let's try again. Sorry about that. I put the wrong one in the wrong folder. Okay, come on. Final exam review. So ignore what I put up there. Let me fix it. Final exam review 1120. There we go. Okay. Remove that link, remove this link. Okay, refresh today's announcement. That'll give you the right link. My bad. I don't know why that was in that folder. I'm gonna put the solutions up there as well. Okay, there we go. That's better. View from CU. Oh, let me put which numbers are supposed to be there. Yeah. Quizzes. So the review is pretty long, but there's a lot of things that aren't important. So just the part one, just the multiple choice stuff. There's no free response. There's no part three or anything. So what's that? Announcements. Yeah, if you check today's announcement, you'll see which problems to do. It looks like this. Maybe I'll pull up the solutions instead. Yeah.
How do you evaluate one like number two?
So 11 pi over 4, we have to figure out what that is within the unit circle. And so obviously that's more than 2 pi around. And so what I would do is I would say, okay, I want to take 11 pi over 4 and I want to get myself back to the unit circle by either adding or subtracting as many 2 pi's as I need to. And that's 3 pi over 4. So when they ask you to find something like cosine of 11 pi over 4, they're really asking you to find the cosine of 3 pi. Yeah. Hey, you had your hand up for a little while. Sorry about that.
No. Did you say we were allowed to use our unit circle?
Yes.
On the thing?
Yeah.
Yes, ma'am. Thank you.
Mm-hmm. This might be worth kind of like, scanning through the questions that I listed and seeing if there's anything that you'd like to see now. Easier for me to explain it to you now than later tonight if you're looking at stuff. So. only one that sticks out in my head would be like domain and range of those trig functions. We did that back in Precalc. You'll want to look back, or look, maybe it's January. You want to look back at those notes to recap. Right? Sine and cosine, domain and range is all real numbers, but the range is -1 to 1. Tangent has all these asymptotes at pi/2 and 3pi/2, but they're all cyclical, so they're when you solve them, they've got this periodic nature to the domains or their ranges or their solutions or whatever it may be. So worth looking back and stuff. Things like 9 and 10 there. Put those quiz 3.1 grades in there. Wanted to check those out. In general, not too bad. It's a little disappointed in those of you that clearly looked at something else to help you with the ones you might have gotten stuck on. Because I can tell when you do that. So that was a little disappointing to see. But I know you're wanting to do well and get it, but I was hoping not to see some of the things that I did end up seeing. But in general, it looked like a lot of us just did a great job. So that was nice to see, especially on the stuff that is not easy. I'll start looking at the exponential and log derivatives today. Hopefully get that in for tomorrow. So seniors, you know where you're at by the time you're done with this week. And tomorrow is the day that you'll get your chapter 4 guided notes as well. So you have those ready to go for Monday in case you're not here for whatever reason or sick or whatever it is. I will not be here a week from tomorrow. Baseball is in Grand Junction for the weekend for a road trip, so we're playing 2 games on Friday. So we're leaving either Thursday night or Friday morning. So there will be a sub in here. It will be Mr. Fields from maybe your old geometry honors a couple of years ago, if you have.
I was at the wrong school when I took geometry, so.
Really?
Right.
Well, look, here you are now, right?
Yeah.
All is well.
Well,
So I don't know how much calculus he remembers, but at least we'll have a math person in the room. So as you're working through whatever we'll be working through on that day. Next Friday, May 7th, which is senior checkout day. So seniors, you guys are done at that point. But everybody else will be doing something. We'll just see how much. I have 2 personal days that if I don't take them, I lose them. I don't know when that's going to happen, but probably like during my Algebra 2 finals or something like that. Because that one's athletic, so I don't do that. My sick days, I can roll over. I can keep them from year to year. But personal days, I lose if I don't use them. So I'm using them. Because I don't know if you've noticed, but I've taken this many days off this year. This many. Which is about right. I don't know, it's like more work to like get a sub and tell them what to do. Make sure that it works out the way that I want it. I'd rather just be here. But if you're gonna pay me to stay home, yeah, I'm gonna do that too. I'm okay with that. So last 20 minutes or so, let me know if there's something you want me to reteach or look through. Now the topic list is there. I don't know if there's something on there that you just want to hear again. Like number 4, number 5, number 7, number 9, whatever. Tell me what you want. I'll reteach it. I'll do an example of it. I'll give you some extra practice. I need 2 more practice problems, whatever. Yeah, Jess.
We'll do like reference angles.
Okay, so a reference angle is the angle between the x-axis and the terminal side of whatever angle that we open up. And so if I open up an angle to here, right, there's my terminal side. The reference angle is how close it is to the x-axis. So, I open up an angle of, let's say this whole big theta is, 231 degrees or something like that to get me into that quadrant. What I'm trying to figure out, let's call this alpha, is trying to figure out what angle it makes with the x-axis, because then if I wanted to, I could draw a right triangle and know what every angle size is. That's what reference angles are so useful for. It's kind of getting us away from, hey, the unit circle is this big 360 degree thing. Let's get ourselves back into right triangles where this angle is always going to be acute. And so the whole thing is 231. So it's like from here to here is 180. How many more to get all the way to 231? Well, that would be 51, and that would be your reference angle. Usually when they ask about reference angles, they even pick really nice initial thetas, like unit circle thetas, like 225 or 240 or 315, or something actually in the unit circle. But when they ask you for the reference angle, it's always that one right there, the one created between the x-axis, whether positive side or negative side doesn't matter, and the terminal side of whatever angle you go. And I usually just draw a picture, and then I feel like everything that's geometrically trigonometric, right? All the stuff we can draw pictures of makes it a lot easier to worry less about, oh, there's a formula for this, and I can do, 231 equals 180 plus alpha and solve for it. There's all these rules and stuff depending which quadrant you're in. Just draw the picture, see if you can figure out what angle the x-axis and that terminal is. And it's only second, third, and fourth quadrant, because if you're in the first quadrant, your theta is your alpha. It is your reference angle, so we don't have to worry about that. The last day to get anything late into me, if there's anything that you're missing, would be the last day of classes, okay, which is May 18th. Okay, our final's on the 19th anyway, so. But I'm setting a date for all of my classes, May 18th, because that'll give me a chance to actually grade it and make sure that it's up to date before we guys get you out of here.
Nathan,
Sure.
Could you like a refresher on like equations of, I don't know, like where you have find phase shifts, amplification.
Sure. This one. So the types of questions they could ask would be like, here's an equation, what's the amplitude, what's the phase shift, what's the vertical strip, whatever. Or they could say, here's all that information, now make an equation where that's true. So let's talk about both of those separately. The setup, whether it's sine or cosine, I'm always just going to kind of use sine, could look like this. Okay, where they don't factor out the B, the frequency, and that makes it a little bit trickier. Right, A is your amplitude, B is your frequency. The phase shift isn't C. The phase shift is when they actually do the right thing. They factor the B out. C over B. That's your phase shift. And sometimes they give you the equation with it factored out. You don't have to do anything. It's just whatever's on the inside. Cool. Sometimes they don't, right? Sometimes they just have the one set of parentheses, not the two. And that phase shift, we actually have to look at and factor the B out, or just do C or B. And get there. Okay, D would be the Y equals D, is what I always call it, the midline, or you can just say D is your vertical shift. The other thing that also comes up is they talk about the period of a function. Okay, and if it's sine or cosine, It's 2 pi over b. And this is the way that I think that they like to try to trick us with the period. Is, you know, if they give us an equation, for example, let's just make it up, like y equals 3 cosine of 2 theta minus pi over 3 plus 1 or something like that. One of the possibilities for, hey, what's the period, is definitely going to be 2. Like they're just going to put b as an answer, where the real answer should just be pi, right? Because it's 2 pi over b. So if they're giving us a multiple choice option, 2 pi is going to be there, pi is going to be there, 2 is going to be there, and then they'll maybe like 1 or 2 other ones for sure. And so that's definitely one of the ones that gets tricky. The phase shift for this one is pi over 3, not negative pi over 3, right? It's always the opposite there. Okay. The other thing that they'll do though is they won't factor out b. They'll say pi theta plus 1. That's a weird one. Pi theta plus 2 pi. I don't know. Or just 2. Let's just do 2. Sorry. I guess 1 would have been fine. Plus 3, something like that. Where they don't pull the pi out and they ask us for the phase shift. And an answer like negative 2 is going to be there for sure. Whereas the reality is that the phase shift is 2 over pi, c over b, because it hasn't been taken out yet. And obviously 2 over pi is not a nice, you know, phase shift because it's not like that. Just make it up. But you know, maybe those are switched to theta plus pi, and then pi over 2. But really, it's negative 2 over pi, right? Because we have to make sure we change this. And so it's probably going to happen. I think it's both ways. I think they give us an equation. They ask us for something. They ask us for the amplitude, for the period, for the phase shift. I don't think they ask us for the midline. I think that's probably just too easy. But and then they'll give us one where they say, hey, the amplitude is 2, the phase shift is pi, the frequency is, or the period is pi over 2, and the midline is 7. Which of these equations is the right one? And he's got to kind of put those pieces in the right order. And a lot of times with questions like that, there are very small differences between one and the other. It's a plus versus a minus, sine versus cosine, things like that. I think they'll probably avoid that. Usually they say, you know, cosine, 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 all the way down. So just be wary of how it's written. Okay, is the b factored out or not? That's kind of the big thing that they try there. The other thing that they like to do, like I said, with the period versus the frequency. Look careful. If they're asking for frequency, they're just asking for b. If they're asking for the period, that's 2 pi over. Yeah. The topic 4? Yeah, sure.
All right, number 4 on the review.
Oh, even better, yeah. On the review, number 4. Okay. So they're asking us to evaluate the inverse sine of negative radical 3 over 2, which is basically asking the question, hey, what's the angle that has a sine of negative radical 3 over 2? And what we know about unit circle is that there's usually 2 answers out of order. And so they're only going to put one of the right answers on there. Now, if both of the right answers are on there, then they're both correct. Pick either one, doesn't matter. But what this one is asking us to do is say, okay, find an angle that has a y value that's negative radical 3 over 2. And really all you're doing is looking back at the unit circle and locating these 2 spots. Right? This angle way down here at 4 pi over 3, or this angle all the way over there at 5 pi over 3, because they have a y value that is not a negative radical 3 over 2. So 4 pi over 3 would have been fine. Honestly, for me, 5 pi over 3 is also correct, I think. I don't see why that's not right. It's just that negative pi over 3 is a much faster way, right? There's the terminal side. Like, should I go all the way around this way to do it, or should I just take the shorter route and go that way? They want the angle in blue because it's just faster. And your calculator is going to back that up too, right? If you typed in the inverse sine of negative radical 3/2 and you're in degrees, it will give you negative 60. It's not going to give you 300, whatever, 300 exactly, right?
I can figure out how to switch to degrees.
Your calculator. All right, let's see. Oh, I don't know. Let's figure it out together. So you're in meridians right there. Can we just like, okay. Hey, you. I don't want you. I want yours. Damn, that was a lucky guess. I'll take it. Because you're getting, negative 1 point blah, blah. And you're like, I have no idea what that is, right? There's some irrational multiple of pi. I'm glad you brought that up because I did not realize that they put 5 pi over 3 on there and then didn't like it. I will make sure that if that is the case tomorrow, that I let you know. And if it's not the case, to not worry about it. I don't think there's a none of the above correct answer on this one. Yeah.
What do you mean by the general formula?
Which one?
Number 24.
Huh?
Number 24.
24. Okay. Trig functions are periodic, which means they repeat over and over and over again. And so if I'm drawing something like tangents, I'm trying to figure out where is this thing equal to 1, right? Tangent of theta equal to 1. All of these answers are correct. And what they're asking us to do by finding a general formula is asking us to do 2 things. Number 1, where's the first answer? That's this. Give me the first answer that's right. Where on the unit circle do we have a tangent value of 1? And the answer to that is pi over 4, right? Because y and x are exactly the same, and that's what I want tangent to be if it's equal to 1, because tangent of theta is y over x, so I want those to be the same. And so what that does is it kind of like narrows down. This one's gone, and this one's gone. Pi over 3, pi over 6, that's either going to be radical 3 or radical 3 over 3 for those tangents. The question that we want to figure out after that is, how far do I have to go to get to the next right answer? And that's what that plus k pi or plus k pi over 2 is doing, is asking us to go to the next one. Like, okay, if this right here is pi over 4, what's that? Where is it again going to give me basically what's the period of this function? And that's all that this represents, which is the correct period for our function. And for tangent, period of tangent is pi. It is not k pi over 2, or k is an odd edge, so pi over 2, 3 pi over 2, 5 pi over 2. So, I don't have to do that. It's not every pi over 2. It's every pi. So if you can find a couple different answers, right? So pi over 4, and then this one over here was 3 pi over 4. This length from there to there was pi, which is why number 1. That's a trickier one for sure. Yeah. But like inverse tangent of 1 will give you 45 degrees, which is nice. So you can kind of trim it down your options to just A or D, and then trying to find out where it's going to happen again. And that's just your period. Sine, cosine, secant, cosecant, the periods of those are all 2 pi. Just strip around the circle. Tangent and cotangent, the period of those are pi, because they repeat. Like the first and second quadrants, and then repeats in the third and fourth, because we're doing logarithms. Topic 4. Given the sign of two functions, in which quadrants does theta lie? So what they would say is something like, okay, so cosine of theta is positive and tangent of theta is negative. Where's theta? And the thing that I like to do to make this really easy is I'll just kind of look at each one separately and then see where they overlap, because there's 2 quadrants where cosine is going to be positive. There's 2 quadrants where tangent is going to be negative, but only 1 quadrant where they're both true. All right, and so if I'm looking at where is cosine greater than 0, I'm just looking for where x is greater than 0, which is in the first and the fourth quadrant. So I'll just put a little check mark in each one. So okay, that's where that's going to be true. Whereas tangent negative, well, tangent is y over x, and if I want those to be different, if I want them to be negative, I want the sign of y and x to be different. All right? That happens when y is positive and x is negative, or when y is negative and x is positive. Quadrant. Now, they could ask you for secant, they could tell you something about secant. Well, that's just cosine. That's just x. They could have something about cosecant. Well, that's just sine. That's just y. Right? And so kind of relating it back to sine and cosine so you can get it back to y and x. I just draw myself a little sketch. I put some check marks where things are true. I find the only quadrant where all of the things are true. And that's it. And I don't know. Did they give us a question like that? Let's see. There we go. It's like almost exactly the same question, right? So if cosine is positive, okay, so here and here. If cotangent is negative, I basically just gave you the same exact question. Yeah, that's fine. Okay, as things come up tonight, or before the quiz tomorrow, people don't call it a quiz because it's like on campus as a quiz. Before the Trig final for tomorrow, please let me know. I think you'll do great. I'm not going to let it destroy you if you don't. Okay, I will make sure that your grade does not plummet because of something like this. Okay, this is just let's check off this box. Let's get ourselves our 3 credits for college Trig. And let's get back to the good stuff. Let's get back to calculus. So 2.5 weeks of calculus left after this. We'll do as much as we can. We won't get all the way through chapter 4, and that's okay. I'm just going to teach you a handful of ideas at most. We'll get into the second derivative of a function and what that means, what that does for us. And then we'll get into what I've been kind of alluding to for a little while, finding the derivatives of things that aren't functions. And how do we do that? So a couple different strategies there, and that should pretty much do it. We'll kind of ride with that latter idea for sure. So I'll probably actually do some of chapter 4 in a slightly different order than the way that it will be printed for you, because I think it makes most sense to just jump into the second derivative of like polynomials and things that are easy like that, rather than implicit differentiation.
How much are like chapter 4 final?
It's not. It's going to be like just a regular test, so just out of 100. Yeah, I'm not going to weight it like a final and do like 150 or 200 or anything. Yeah, they'll just be a regular chapter 4 test out of 100. And we've already got, gosh, hundreds and hundreds and hundreds of points in that test category. Let's see. Between all of the tests and quizzes and things, let's see. We've got a total of 565 points in this semester total. 1, 2, 3, 4. We have over 500 points already, so it won't make a huge dent. Yeah. Thanks, everybody. Have a good one.
I just noticed
Thank you.
the quiz 5.2
Thank you. You're welcome.
to 5.4.
Yeah.
Like I don't really have a grade in there, so I don't know.
Was
if
that
I
the
was
one?
missing
Was that the one that?
Because I honestly don't even remember what was.
That was so long ago.
Yeah.
Yeah, let me check. See if I have a grade in my separate.
I feel like I haven't missed a quiz or a test, or if I have, I've made it up. But I could be wrong.
Oh, that was the extra one. That was the one. Oh, I feel really good about it. I'm gonna try it.
That's right.
And if it's gonna help you, I'm gonna put it in. If it doesn't, I'm not.
That okay.
That's fine.
Thank you.
Yep.
Hey, Rose.
Hey, Xander.
How you doing?
Pretty good. How you doing?
How you doing?
How you doing? We'll see how many of your compatriots join us today. This is the unofficial senior